Hey everybody, in this video we are looking at example 49 on our playlist of PreCalc final exam review material. This is an inequality that we will be solving. Solve each inequality and graph the solution set on a real number line. Now I initially will graph it using XY plane because that's how I picture it, and then from there I will show you the number line equivalent of that. So we will look at that, and let's just get into this. So when you're solving an inequality, I think it's so important to visualize what the question is representing. This question, actually better this way, this question is representing a parabola. That's what 2x squared represents, right? That's definitely a parabola if it were y equals this thing, right? And it wants to know, when is this parabola less than 0? So if I had y equals this, and I also have y equals that, what are those two things? Well, y equals 0 is the x-axis. And if I'm asking you, when is the parabola less than the x-axis, I'm asking you, when is the parabola below the x-axis? So you say from this x value until this x value with parentheses because it says less than, not less than or equal to. Boom, there it is. All right? And then you could kind of melt that little shaded into a number line and you're done. So how do I find out when this, and also I know it's opening upward because the 2x squared is a positive 2x squared based on how this is set up, right? So how do I know what my x-intercepts are? I need to know that because I need to know where this graph crosses the x-axis. Those are the doorways. Those are the entryways from positive world to negative world. We've got to pass through the x-axis. Now the way we get x-intercepts of a polynomial is we try to factor, and then in this case we would get two linear factors, which makes sense that we would get up to 2 x-intercepts. So if I factor this, I will get 2x and x. I will get 3 and 1 for the others. So if I want a positive 5, so I could do plus 3 minus 1. Outer is plus 6x minus 1x, that's plus 5x. That is good to go. So I'm going to solve for my x-intercepts from here. The way we get our x-intercepts is now 2x minus 1 equal to 0. Do not use your inequality sign anymore for this time being, okay? And x plus 3 also equals 0. 2x equals 1, therefore x is 1/2. And here x is negative 3. Now obviously think about where these are, right? So on a graph or number line, negative 3 would be this way and positive 1/2 would be that way. So that and that would be your x-intercepts, and based on the positive leading term, I know that the wait a minute, I thought I had that circled, but maybe I didn't. Tells me that it's a parabola opening upward. So I'm just going to sketch this for myself so I don't have to test intervals, because testing intervals is for suckers. Also, these are both to the first power. First power means that these intercepts are linear local behavior. So that means you cut through them. The positive also means that the positive 2 on the 2x squared means that the graph finishes pointing upward. So now I'm asking, or being asked, when is this less than 0? Less than 0 is when it's underneath. So I'm really concerned with the part of the graph here. When, for what x values does that happen? So imagine melting that into your x-axis, like if it bent, the bottom went up to the x-axis, the top stuff would go down. What part is going to get the extra shading on it? The number line answer would look like negative 3. I mean, honestly, if you do it the way I did, that's to me better than a number line. Open circles, shaded in between. What's that interval notation look like? Parenthesis, negative 3, comma, 1/2. So this interval notation answer, this number line representation, this total visual graphical representation, boom, that would be your y-axis. Your y-intercept would be negative 3 because plugging in 0 for x, yada yada. It doesn't matter which way you do it. But all you need to get as your final answer with interval notation, let's do that because I think it's better, is negative 3, comma, 1/2 in parentheses, the interval notation for the solution of this quadratic inequality. If you found that helpful and you got it right and you think that this method is better than what you were doing before, well, go ahead, thumbs up. If you are still confused, ask me a question. Let's get this taken care of. Check the check the description box or playlist to find other videos like this. There are 5 more inequalities. I think there's 2 more polynomials and 3 rational function inequalities coming up after this. So look for those. That's it for now. Adios.